Many variables of interest in music and the related social, psychological, behavioral sciences have a qualitative rather than a quantitative interpretation. They take up only a finite set of values, and the outcomes don't necessarily have a numerical meaning. Instead, they represent some type of qualitative information. Here, we're dealing with what's called categorical variables that are limited to a number of different values. In other words, they can only belong to a finite set of categories. An example of this may be gender, an academic major, the grade a student is in, the instrument a student plays, or the state that a student is from. In some of these examples, the order of the outcomes has a natural interpretation. One example of this may be a student's grade, where a student could be assigned to grade 1, grade 2, grade 3, grade 4. In other examples, the order of the outcomes don't necessarily have a natural interpretation, such as a musical instrument that a student plays. Clarinet can be assigned to the number 1, oboe can be assigned to the number 2, trumpet can be assigned to the number 3, and flute can be assigned to the number 4, for example. In R, the structure that we use to manage categorical variables is called a factor. One advantage of using a factor in R is that we can attach labels to certain outcomes. As I said previously, some of these outcomes can have a natural interpretation related to a number, as in a student's grade, grade 1, grade 2, grade 3. In another example, there isn't necessarily a natural interpretation, such as a student's instrument assigned to a particular number. In other examples, the outcomes have quite an important interpretation. An example of this might be a Likert scale used in a survey, where the number 1 can be associated with the response of strongly disagree, 2 can be related to the response of disagree, 3 can be related to the response of agree, and 4 can be related to the response of strongly agree. In this example, the numbers represent an increasing quantity of the amount of agreeableness a respondent has to a survey item. Let's say we distribute a survey to 10 high school music students. For part of the survey, we ask them to provide the information of what musical instrument they play. So what we've done here is we've assigned a vector of musical instruments played by the respondents. The vector's name is musical instrument, and we've used the concatenate function to list each of the instruments that the students play that we've asked them to respond. And here we have 10 responses of musical instruments. So we run the code and we notice here that it comes back as a character vector of 10 elements that include each of the instruments. If we come down here and type in the vector name, it provides us the list of 10 instruments. And R here doesn't yet understand that we're working with categorical variables or factors. It just reads it as a list of character elements. To convert the character vector to a factor vector, we can use a factor argument. So we can create a new object, we'll call it music instrument, but then I'll also specifically identify it as a factor. And then we'll use the factor function. And the argument that I can pass to the factor function is the original character vector itself. I'll run the code, and we'll notice in the global environment that we'll have a new vector. It's a factor vector with 6 levels. I can come down to the console and read in the new factor vector. And we notice that the output looks a little different here. No longer are there quotes around each of the levels, and it identifies the levels here. Clarinet has been assigned the number 1, flute has been assigned the number 2, oboe 3, saxophone 4, trombone 5, trumpet 6. And we'll notice that the levels have been assigned alphabetically. So to briefly go over what happened, R scanned through the original music instrument vector and sorted each of the elements alphabetically. From there, what it did was that it assigned an integer to each of the categories based upon its rank order alphabetically. So we need to keep in mind that a factor vector is actually encoded as an integer vector. And the reason it's done that is for working memory within R. If we have long strings of categories, it's faster for R to sort through the strings as integers as opposed to the strings themselves. So just keep in mind that under the hood, a factor vector is actually an integer vector, but it reveals itself for our use as a factor vector. In order to demonstrate this, what we can do is we can use the structure function in order to look at the actual structure of the new factor vector that we created. So the structure function is str, sometimes it's called the stir function. And for the argument, I can pass the new musical instrument factor vector. And here it reveals to us that it's a factor vector with 6 levels, clarinet, flute, etc. And then it gives us the actual integers that are coded to each of the categories. So if we assume here that the levels are clarinet 1, flute 2, oboe 3, saxophone 4, trombone 5, trumpet 6, we can compare these integer numbers to the ordering of original musical instrument vector. So oboe is 3, clarinet is 1, saxophone is 4, saxophone is 4, all the way through the rest of the vector. Now in this case, having R automatically assign integers to the categories based upon their ordering alphabetically is perfectly fine when we're working with categorical variables that are nominal in nature. In other words, where the ordering doesn't necessarily have a numerical meaning. However, in the case of a categorical variable that's ordinal in nature, where we need to specify a particular order to the categories, we can specify the levels argument within the factor function. And this is something that we'll do in the next video.